Hi everyone, in this video we will see about EMF equation of DC generator. So before going to derive the EMF equation of DC generator, first we have to assume some of the notations. So here we are assuming pi is equal to flux per pole in Webers, Z is equal to total number of armature conductors or coil side on armature equal to, that is equal to number of slots into number of conductors per slot. P is equal to number of generated poles. So, A equal to number of parallel paths in armature, N is equal to rotational speed of armature in revolutions per minute. So, that is RPM. N we are measuring in terms of RPM. E is equal to EMF induced in any parallel path in armature. So, these are the notations we are assuming. Coming to the derivation of EMF equation of generator. So, generated EMF EG is equal to EMF generated in any of the parallel path, that is E. We are considering E is the generated EMF, and average EMF generated per conductor is equal to d pi by dt. So, because N is equal to 1, N is number of turns. So, during one revolution of armature in a p pole generator, each armature conductor cuts the magnetic flux P times. Flux cut by one conductor in one revolution is equal to pi p Webers. Next, flux cut by each conductor per second equal to flux cut by the conductor per revolution into number of revolutions of armature per second, pi p into N by 60 Webers. As per Faraday's laws of electromagnetic induction, EMF generated per conductor equal to d pi by dt, that is equal to pi p N by 60 volts. So, there are number of conductors in DC generator. So, it is connected series between positive brush and negative brush. So, the EMF is equal to total number of conductors divided by the number of parallel paths. So, it means that the number of armature conductors parallel path equal to Z by A. Now, finally, the total EMF generated in DC generator, that is the generated EMF EG is equal to EMF generated per conductor into number of conductors in each parallel path. EG is equal to pi p N by 60 into Z by A volts. So, this is the EMF equation of DC generator. So, suppose if you consider different types of armature winding generators. So, here we have two types of windings we are using in DC generator. One is wave type of winding, another one is lap type of winding. For a simplex wave wound generator, number of parallel paths A is equal to 2. From equation 1, Eg is equal to pi p N by 60 into Z by 2. So, generally the formula EMF generated is equal to pi p N by 60 into Z by P, right. So, here P Z by A, right. So, A is equal to 2, that is what here we are substituting. So, for a simplex wave wound generator, the EMF equation Eg is equal to pi Z P N by 120. Coming to the wave type DC generator, EMF equation Eg is equal to pi p N by 60 into Z by P, but for wave type wound, number of parallel path is equal to number of poles, that is A is equal to P. So, by substituting A is equal to P in EMF equation of DC generator, generated EMF Eg is equal to pi Z N by 60 volts. So, this is the EMF equation for different armature winding generators. One is wave type, another one is lab type, right. So EMF equation is very important, this derivation practice very well. And next we will see the relationship between induced EMF and terminal voltage with an enumeration of brush contact drop. So this is one of the important relation for doing problems. So here induced EMF EC is equal to terminal voltage Vt plus armature drop Ia Ra plus V brush drop. So here induced EMF E is equal to Vt plus Ia Ra plus V brush drop. So V brush drop is brush contact drop for simple or for small type generators. For small rating generators, the V brush drop is very less. It may be 0.5 volts or 1 volt. For those small rating generator, this V brush drop is neglected. So after neglecting the V brush drop, the relation induced EMF and terminal voltage and brush contact drop is we are neglecting. So E is equal to Vt plus Ia Ra, right. So next video will see about back EMF and significance, right. Thank you. If you have any doubts, please comment in video, and you can contact through WhatsApp or through calling, right. Thank you everyone.